Biochemical oxygen demand. The biochemical oxygen demand, BOD test, was originally performed in England as a way to estimate the organic strength of wastewater. There are so many different organic compounds in wastewater that it would be very expensive and nearly impossible to measure them each individually. Instead, the BOD test measures how much oxygen is needed by the bacteria to stabilize the biodegradable organic material present in the wastewater. Biochemical oxygen demand allows regulators to estimate the effect the effluent from a water reclamation resource facility might have on a river or lake. When excessive amounts of BOD are discharged to a river or lake, it can overwhelm the natural treatment capacity, consume most or all of the available oxygen, and result in fish kills and other environmental degradation. The treatment capacity of a water resource reclamation facility is expressed in terms of how much flow it can treat in cubic meters per day, million gallons per day, and how much organic material it can process in kilograms per day or pounds per day. The BOD test is conducted by taking a sample of wastewater, diluting it if necessary to bring it within the measurable range of the test, measuring the starting dissolved oxygen concentration, incubating the sample at 20 degrees Celsius or 68 degrees Fahrenheit for a fixed period of time in the dark, and then measuring the ending dissolved oxygen concentration. Figure 1.1. The BOD concentration in milligrams per liter is calculated from the amount of oxygen consumed over the test period divided by the sample size used. The reason the test is conducted over a 5-day period is because the longest river in England is the Thames River. It takes approximately 5 days for water to flow from London to the ocean. Once the wastewater reached the ocean, it was thought that any remaining BOD did not matter. Similarly, the test is conducted at 20 degrees Celsius because the warmest the Thames River got in the summer was 18.6 degrees Celsius or 65.5 degrees Fahrenheit. The test was standardized by rounding up to 20 degrees Celsius. The more organic material that the wastewater contains, the more oxygen the bacteria will use to consume and stabilize it. By definition, 1 kilogram of BOD will consume 1 kilogram of oxygen. Also, 1 pound of BOD consumes 1 pound of oxygen. The BOD is thought of in terms of organic strength, but the test really measures how much oxygen is needed to treat or stabilize the wastewater. The BOD can be either solid organic material, like bits of food from a garbage disposal, or dissolved organic material, like sugar in tea. The BOD can be further divided into carbonaceous biochemical oxygen demand, CBOD, and the nitrogenous oxygen demand, NOD, as shown below. The amount of oxygen used in the BOD test that goes toward breakdown of organic material is the CBOD. Additional oxygen may be used by a special group of bacteria, the nitrifying bacteria, to convert ammonia to nitrite and nitrate. This reaction consumes 4.5 kilograms of oxygen for every 1 kilogram of ammonia converted to nitrate. When this reaction takes place in the BOD test, the additional oxygen demand is the NOD. If an analyst wants to measure only the CBOD, a substance that is toxic to the nitrifying bacteria will be added to the BOD test. For raw domestic wastewater influent, the CBOD is typically approximately 85% of the total BOD. WEF 2012. The BOD consists of both soluble dissolved and particulate fractions. If a wastewater sample is filtered through a piece of filter paper, some of the organic material will pass through the filter and some won't be able to pass through. The organic material that goes through the filter is the dissolved or soluble BOD. The organic material that remains on the filter paper is the particulate BOD. A can of soda contains a lot of sugar that is both organic and able to pass through a piece of filter paper because it is dissolved. The percentage of BOD that is soluble depends on the size of the collection system and the types of customers served. For domestic wastewater, including light commercial, such as stores and schools, soluble BOD is typically between 20 and 40% of the total BOD. WEF 2012.